Hey there and welcome back. My name is Ms. Danielson and today we're looking at frequency diagrams. Now when I say frequency diagrams, I hope you have a basic knowledge of what that means. These are types of graphs where the frequency is plotted up the side of the graph so you can clearly see how many people responded to a question in a certain way. This lesson will focus mainly on an introduction to histograms, but a lot of it will be spent comparing and contrasting both histograms and bar graphs. Some of the basics that you should already know about bar charts is that for a bar chart, the bars are separated. That means there's a space in between them. This is because the data on a bar chart is discrete. It could be qualitative, that is non-numerical, or quantitative, that is numerical. But if it is numerical data, that data would be whole numbers, not decimal numbers like 0.57, but rather 1 or 2 or 3. Bars are labeled directly underneath, and let me show you an example so you can understand what I mean. Here I've got a bar graph of favorite types of movies. This is called a frequency diagram because the frequency is shown up the side of the graph. And by frequency, I mean the number of responses. When asked, what's your favorite type of movie? It looks like 4 people decided that comedy was their favorite type of movie. 5 people said action, 6 people said romance, 1 person said drama, and 4 people said sci-fi. Comedy, action, romance, drama, and sci-fi are labeling the bars directly underneath, and these are an example of qualitative data. It's non-numerical, and this data is discrete. They could either choose comedy, action, romance, drama, or sci-fi, but not some type of movie which is in between these bars, hence the spacing. Histograms, on the other hand, is another type of frequency diagram where the bars are touching. This is because the data is not discrete, the data is continuous, or possibly discrete but grouped. What I mean by continuous data is that it could involve decimal values or values which fall in between a range of values. The bars in the case of histograms, strictly speaking, should not be labeled underneath the bars, but at the very beginning of the bar to the very end of the bar, showing the range of values that are demonstrated by that bar. Again, let's see an example. Here I've got a histogram of the number of oranges on a tree. And here I've got several different trees, and across the bottom, I've labeled how many oranges are on those trees. But it's not just one discrete number of oranges. This first bar shows the number of trees with between 0 and 5 oranges on it. And again, it's a frequency diagram because up the side, these numbers tell me how many trees had between 0 and 5 oranges on it. There were 6 trees with between 0 and 5 oranges on it. There were 8 trees with between 5 and 10 oranges on it, and so on. These bars are not labeled directly on the bottom. They are labeled at the beginning and ends. The data is continuous because this bar shows how many trees have between 0 and 5 oranges. And the next bar shows the number of trees with between 5 and 10 oranges. There is no space for gaps in between these bars because one bar ends precisely at the value where the next bar will begin. If one of the main differences between histograms and bar graphs is that bar graphs have separated bars because the data is discrete, and histograms have touching bars because the data is continuous, let's have a look at the different types of data and how we would analyze them and graph them. So far, we've been talking about qualitative data and quantitative data and discrete data and continuous data. So here are all the possible combinations of data. Let's start with the qualitative discrete data. Qualitative being non-numerical, and discrete meaning it's one value or another, but nothing in between, not some value within a range of values. If it's discrete data, as we said before, discrete data would be shown on a bar graph because we want to show separate bars where no data could fall in between them. So here's an example of a question which might give qualitative discrete data. What's your favorite animal? Suppose I asked this question and I got this set of raw data. Some people like cats, some people like dogs, some people like fish, some people like horses, and some people like octopus. Okay, that's a kind of weird choice for a favorite animal, but I think we can all agree that this data is qualitative. It's not numbers. It's also discrete because a person might have chosen a fish as their favorite animal or a bird as their favorite animal, but nothing in between. Although this data is qualitative, so not a number, we can still count how many people chose cat as their favorite animal to make a frequency table like this. But don't confuse the frequencies with the data. This is non-numerical data. Cats, dogs, birds, fish, horse, and octopus are not numbers. However, I can work out how many people chose these animals as their favorite animals. And in order to work out my frequency for my frequency table, as you can see, I just looked for the cats and I see there's 1, 2, 3, 4 cats. I looked for the dogs. I see that there's 1, 2, 3, 4 dogs. Birds, there's 2. Fish, there's 2. Horses, there's 2. And octopus, there was 1. One way that I can check, I can try adding these up. I see over here, I've got 3 rows of 5. 3 times 5 is 15. And this adds up to 15. The order that I put these animals in doesn't really matter for qualitative data because there is no numerical order that I need to follow for cat, dog, bird, fish. Who knows what order they need to belong in? I have no logic I need to follow. So I'm going to go ahead and draw my bar graph now. For my bar graph, I need to make sure that I have enough space to make the tallest bars. Look at the frequencies. My highest bar needs to reach up to 4. So I made my frequency axis reach up to at least 4. I followed a nice clear scale. My bars are nicely spaced out. I've got a title. I've labeled each of my bars underneath, and don't forget to label your axes. This vertical axis will always be my frequency axis, and my horizontal axis has to be somehow related to my title. The bar chart for favorite animals is the title, so I've got my favorite animals plotted across the bottom. Next, let's see an example of quantitative discrete data. Again, since it's still discrete data, we should display this on a bar chart. But quantitative data, as opposed to qualitative data, is numerical. So for example, if I ask the same question about favorite animals, but instead of what's your favorite animal, I ask how many legs does your favorite animal have, I've got the same data, but now it's numerical data. Cats have 4 legs, dogs have 4 legs, fish have 0 legs, and so on. I think we can now agree that this is now quantitative data. It's numerical, but it is still discrete because although these are numbers, they are all whole numbers. I'm assuming no animal has some fraction of a leg. When making a frequency table for numerical data, make sure that you put it in the correct order. I'm not just going to randomly have 4, then 0, then 2, then 8. Let's start with the smallest value and work our way up to the biggest value. So how many animals had 0 legs? I see there's 2. How many animals had 2 legs? I see there's 2. How many animals had 4 legs? I counted them all up and I see that there is 10. And how many animals had 8 legs? I see that there is 1. Now that we've got quantitative data, that is numerical data, be very careful not to confuse what the data is with what the frequencies are. I don't want to confuse and think that there are 4 animals with 10 legs. There are no animals here with 10 legs. There are, however, 10 animals with 4 legs. A common mistake that people make on exams is when looking at frequency tables like this and asked what the mode is. They'll say, ooh, the mode, the most common. I see 2 2s here. The most common number of legs would be 2, right? Wrong. The mode is the most common response. And in this case, the most common response is 4 legs because it's got the highest frequency. There are more responses which are 4 than any other number. So our mode is 4. Now that I've ordered my values in order in the frequency table, I'm ready to make a bar chart. I've got a bar chart for the number of legs of animals. I've labeled it with a nice title saying what kind of graph it is and what it's about. I made sure that my axes were high enough to reach the tallest bar, the highest frequency, which was 10. And I've labeled my bars underneath with the numbers of legs that they represent. The order is important this time. I've ordered my bars from smallest to biggest. I could have drawn this in another way. Notice that there were no animals with 1 leg, 3 leg, 5, 6, or 7 legs. I could have drawn bars for those ones and still kept things evenly spaced, but it's not necessary. What is necessary, however, is that I label my axes. Remember, this is a frequency diagram. The frequency is always labeled up the vertical axis, and these numbers across the bottom represent the numbers of legs of these animals, so make sure that's labeled as well. Next, let's have a look at qualitative continuous data. Now, qualitative data, that's non-numerical data. And continuous data is generally thought of as decimal values, so numerical data. So is it possible to have qualitative data, non-numerical data, which is continuous? So it's not simply one response or another, but it could fall in between those responses. Qualitative data is non-numerical, like a favorite animal or a favorite genre of music. So it's hard to imagine how it could be expressed on a continuous scale. But consider a question where you may not be entirely sure which response to choose because you might feel like you're in between two responses. For example, are you an introvert or an extrovert? Introverts tend to feel more comfortable or feel more energized when they're on their own, whereas extroverts tend to be more energized when they're in a group of people. If I were to ask you this question, would you be able to answer definitively, I am introverted. I like time to myself to feel comfortable. Or I'm an extrovert. I need to be around other people to make me feel comfortable. If I ask that question and I manage to get this set of raw data, it definitely looks discrete, not continuous. I've got a bunch of introverts and I've got a bunch of extroverts. I can count how many introverts there are and how many extroverts there are. And I've got this discrete data that I can display on a bar chart. However, I don't think this is a question that you can really answer one way or another. I think there is definitely a range of answers between being a complete introvert and being a complete extrovert. So rather than asking, are you an introvert or extrovert, I might be more inclined to ask, how introverted or extroverted are you? And asking that question, I might get this set of possible results. The person who previously said that they were an introvert might actually want to say that they are very introverted. This person who said they were an extrovert might usually be extroverted, but not always. This introvert might only be slightly introverted. You see where I'm going here? That's not one response or the other, but it could be anywhere within a certain range of responses. While these responses are still qualitative, they're not numbers, they don't seem to be so discrete anymore. It seems like everybody's answering whether they're introverted or extroverted, but within some scale between being extremely introverted to being extremely extroverted. But it's very difficult for me to understand what slightly introverted means. Because if you're slightly introverted, doesn't that mean you're also slightly extroverted? I'm not even sure the person who said slightly introverted understands what they mean. So rather than asking for a qualitative response, that is a non-numerical response, it might make sense to make this clearer to ask for some quantitative response. Ask for a number on a scale of 0 to 1, 0 being completely introverted and 1 being completely extroverted. What score would you give yourself as an extroversion score? So the higher the score, the closer to 1, the more extroverted you are. Here are some results that I might get from these same people. The person who originally said they were introverted, who later corrected that they are very introverted, might give themselves a score of 0 on my extroversion score from 0 to 1. Whereas this person who said they were extroverted, who later said they're actually very extroverted, might give themselves a score of 0.99. That is nearly a perfect score for extroversion, a complete extrovert. Everybody gave themselves a score between 0 and 1, and now this data definitely doesn't look discrete anymore. It definitely looks continuous because these are decimal values that could lie between any given values between 0 and 1. My data is not only continuous now, but it's also quantitative. So when I talked about qualitative continuous, and I wasn't sure if it was possible, I did think of a qualitative continuous example because we said you may not be introverted or extroverted, but somewhere in between. But to help with the analysis of this, I'm no longer dealing with qualitative continuous data, I'm dealing with quantitative continuous data. In this continuous data, we are unlikely to see several of the same values. In fact, looking at the values I've got here, I don't see anybody with the same extroversion score. So I'm not likely to make an individual bar for each of these scores. For this reason, our data needs to be grouped. When I group my data, I will make bars which cover values between one value and another. Suppose I want to make 3 bars here. I know that my data goes from 0 up to 1, and I want all 3 of my bars to have the same range of values. So I've got from 0 up to 1/3 will be the first bar. From 1/3 up to 2/3 will be my second bar. And my third bar will be from 2/3 up to 3/3, which is a whole. Once you've worked out what the range of values are for each group, setting up our frequency table is very similar to how we set it up for discrete data. We just need to count how many of these values are between 0 and 1/3. That's 0 and 0.3 recurring. And I've got 3 of them, 0, 0.24, and 0.12. And then I count how many values are between 1/3 and 2/3. That's between 0.3 recurring and 0.6 recurring. And there are 6 of them. That's these ones in orange. And then finally, I count how many are between 2/3 and 1 whole. That's between 0.6 recurring and 1 whole. And that's these 6 here. Once I've got my grouped frequency table drawn, I can set up my histogram. And for my histogram, I obviously need these bars in order because one bar ends where the next bar begins. So I'll start with 0 and I'll work my way up to 1 whole. The first bar shows that between 0 and 1/3, there are 3 people with scores within that range. Notice I didn't label the bar directly underneath. I labeled at the beginning and at the end because this is not the number of people with one specific score. It's the number of people whose scores fall within this range. There is no gaps between these bars because, again, this bar ends where the next bar begins. This bar ends where the next bar begins. When I drew my frequency diagram, I labeled the frequencies up the side and made sure I had a high enough axis to reach the highest frequency from my grouped frequency table. I give my graph a title, including the type of graph it is. It's a histogram because my data is continuous, and it's of personality types or introversion, extroversion. I'll label my axes. As always, my frequency axis up the vertical axis is labeled frequency, and across the bottom, I've labeled extroversion score, or E, because these values represent the different E scores or extroversion scores that we came up with for how introverted or extroverted someone was. Now that we've seen examples of all the different types of data, let's have one last closer look about how we set up our histograms compared to our bar graphs. Before we can draw a histogram, the values must first be grouped into classes so that the bars can be drawn for each class rather than for each discrete value. For example, here are the wingspans in millimeters of 25 different butterflies. Because of the level of accuracy here, that is giving decimal values, I don't see very many repeated values here, so it wouldn't make sense for me to draw individual bars for each value. It makes a lot more sense for me to group these values and draw a histogram for ranges of specific values. The axes of histograms are much like bar graphs with a few important differences. The bar graphs and histograms both have frequency labeled up the side axis. However, although the bottom axis for a bar graph labels the bars directly underneath, for histograms, the bottom axis labels the bars with the class width boundaries at the beginning and the end of each bar. So here I've got green, yellow, orange, blue, red for my bar graph, whereas on my histogram, I've labeled the beginning and end of each bar with the boundary values. The first bar is for values 0 to 5. The second bar, which has a frequency of 0, is for values 5 to 10, and so on. Notice that each of these bars is the same width because the value at the beginning of the bar and the value at the end of the bar always have a difference of 5. This will always be the case in the beginning when we start drawing histograms. In future, you may see histograms like this because the boundaries will not have an equal difference. This bar, for example, is much narrower than this one because the values at the beginning and end would be closer than the values at the beginning and end of this bar. Don't worry about histograms like that for now. They should not be coming up at least into GCSE. So coming back to our example about the butterflies. Here are my 25 different butterflies, and here are the boundaries I've been asked to graph from. Notice that my boundaries 20 to 25, that's a range of 5. The boundaries from 25 to 30, again, is a range of 5. And the boundaries from 30 to 35 is a range of 5. I just need to look at my data and find how many values there are within these ranges and work out the frequencies that way. I found that there are 10 values between 20 and 25. I found that there were 7 values between 25 and 30, and I found that there were 8 values between 30 and 35. Feel free to hit pause and check that I've done that correctly. My quick way of checking that is to see that 10 plus 7 plus 8 adds to 25, and I know that there's 25 different butterflies altogether. Going forward, let's go ahead and set up our histogram. To set up that histogram, keep in mind how we're going to set up our axes. I'm going to draw a vertical axis for my frequency. And in order to do that, I need to make sure that my frequency axis is at least as high as the highest frequency from my frequency table. Looking at my frequency table, the highest frequency was 10. So make sure I've got enough space to get from 0 up to 10 on this frequency axis. When I'm labeling my axis, make sure that I equally space out my values. So every square or maybe every centimeter, I've made a marking on my frequency axis. I also need to choose an appropriate scale for my horizontal x-axis, taking into account the highest and lowest data values. Remember, these are my data values over here on this side. These are just my frequencies. So across my x-axis, I need values from 20 up to 35. Now it's strange to start my axis at 20 because I know my frequency starts at 0. So very often I'll put a little break in my x-axis to show that I'm not starting at 0. So I've got my axes drawn. Let's start labeling them. I've labeled my vertical axis, my frequency axis, and I'm counting by 2s to get up to 10. Be careful not to number the squares in between the markings. I'm labeling the lines. Labeling my x-axis, I've made a break in my axis to know that I'm not starting at 0. And now again, I'm following a consistent scale. Everywhere along my x-axis, I'm doing jumps of 5. So 20 to 25, 25 to 30, and 30 to 35. This is all nice and evenly spaced, and I don't worry about leaving 4 squares in here to get to 20. I have the break in the axis to explain why that wasn't necessary. Only once our axes are correctly set up can we start drawing our bars. Our first bar, as we see, is between values of 20 and 25, and it has a frequency of 10. My second bar was for values between 25 and 30 with a frequency of 7, that's right here between 6 and 8. And my last bar was for between values of 30 to 35, and it had a frequency of 8. Remember that my bars need to be touching because this bar shows all values up to 25, and this bar starts exactly at 25 and shows all values up to 30, and this one 30 to 35. Don't forget to label your axes. I've got my frequency axis labeled already, but I need to label my bottom axis. What is this? This is millimeters. Millimeters of what? Unless I have a title, I won't know. And it should include what kind of graph this is. This was continuous data, so I drew a histogram of the wingspans of 25 butterflies. And there you have it. So now that you know the difference between histograms and bar graphs, and discrete and continuous data, and qualitative and quantitative data, I hope you feel ready to draw your own frequency diagrams now. I hope you found this lesson helpful. Please leave a comment down in the comment section if there's anything that I left a little bit unclear, or just to let me know how you're getting on. Till next time, keep practicing, and I'll see you soon. Bye.